Jurisdictions vary in their temporary power requirements. Let's examine some minimum requirements and optional considerations along with recommended procedures. Several jurisdictions maintain distinct approaches to temporary power installations. Firstly, San Jose, California requires proof of service to the panel board, with only one plugged-in GFCI receptacle installed on the job site. Seattle, Washington mandates service to code, with all required circuits operational and GFCI protection for all temporary power outlets. Portland, Oregon also requires service to code, with all required circuits operational, extending GFCI protection to all portable equipment used on the job site. Baltimore, Maryland specifies service to code, emphasizing a dedicated panel board for the temporary power and GFCI protection for all outlets. Denver, Colorado permits service to code, but limits it to only one plugged-in GFCI receptacle installed on each floor of the building. Considering these examples, some proposed minimum requirements would be service to code, ensuring all required circuits are operational, and implementing GFCI protection for all temporary power outlets. Optional additional requirements might include GFCI protection for all portable equipment used on the job site, similar to Portland's requirement. A dedicated panel board for the temporary power, aligning with Baltimore's practice, could also be considered. Limiting the installation to only one plugged-in GFCI receptacle installed on each floor of the building, like Denver, is another option. Also consider including a /H and a /C breakers installed only in the panel boards with one 120 volts and / one 240 volts GFCI protected outlet suitable for wood floor sanding and wood trim work. In terms of procedures, several steps can be implemented. Firstly, the contractor must submit a permit application to the electrical department. Secondly, an electrical inspector must inspect the installation before the temporary power is energized. Thirdly, the contractor must provide proof of GFCI testing every 30 days. Finally, temporary power must be disconnected and removed when the job is complete. In summary, to ensure safety and compliance, several elements must be considered. It is essential to provide service to code, ensure all required circuits are operational, and guarantee GFCI protection for all temporary power outlets. Additional requirements can encompass extending GFCI protection to portable equipment, utilizing a dedicated panel board, or limiting the number of GFCI receptacles per floor. Implementing mandatory procedures such as permit applications, inspections, regular GFCI testing, and timely disconnection of temporary power can significantly enhance safety and compliance on construction sites. To elaborate on these elements, let's consider service to code. This means the temporary power installation must comply with the applicable electrical codes and standards in the jurisdiction, often the National Electrical Code. It includes proper wiring methods, overcurrent protection, grounding, and bonding. Ensuring all required circuits are operational means that the temporary power system must provide sufficient capacity and outlets to meet the needs of the construction activities. This involves calculating the load requirements and providing the appropriate number of circuits and receptacles. GFCI protection for all temporary power outlets is crucial for preventing electrical shock hazards. GFCI devices detect ground faults and quickly interrupt the circuit, protecting workers from dangerous electrical currents. Extending GFCI protection to portable equipment further enhances safety by protecting workers from hazards associated with faulty equipment. A dedicated panel board for the temporary power helps to isolate the temporary power system from the permanent electrical system, reducing the risk of overloading or interfering with the building's electrical system. Limiting the number of GFCI receptacles per floor can help to prevent nuisance tripping of GFCI devices due to cumulative leakage currents. Requiring permit applications and inspections ensures that the temporary power installation is properly designed and installed by qualified personnel. Regular GFCI testing verifies that the GFCI devices are functioning correctly and providing adequate protection. Timely disconnection of temporary power prevents unauthorized use or tampering with the temporary power system after the construction project is complete. It is important to consult with local electrical officials and review the specific electrical codes and standards in the jurisdiction to determine the appropriate minimum and maximum requirements for temporary power installations. The considerations outlined here can serve as a guide for jurisdictions in developing or revising their temporary power requirements. Remember, these considerations are not exhaustive and may need to be tailored to the specific needs and circumstances of each jurisdiction. The goal is to create temporary power requirements that are both safe and practical, promoting a safe working environment for construction workers while minimizing disruption to the construction process. It is worth reiterating that electrical safety is paramount, and temporary power installation should always be treated with utmost care and attention to detail. This attention will ensure the safety of workers and the integrity of electrical systems. In addition to code compliance, it's critical to emphasize proper training for all personnel involved in the installation, maintenance, and use of temporary power systems. Training should cover topics such as hazard identification, safe work practices, proper use of personal protective equipment, and emergency procedures. Furthermore, regular inspections and maintenance of temporary power systems are essential to identify and correct any potential hazards. Inspections should be conducted by qualified personnel and should include visual checks of wiring, connections, and GFCI devices. Maintenance should include replacing damaged or worn components, tightening loose connections, and verifying the proper functioning of GFCI devices. Moreover, it is beneficial to establish clear communication channels between the construction team, electrical contractors, and local electrical officials. This will help to ensure that everyone is aware of the temporary power requirements and that any questions or concerns can be addressed promptly. Finally, it is recommended to document all temporary power installations, including permit applications, inspection reports, and maintenance records. This documentation can be valuable for tracking the history of the temporary power system and for identifying any trends or patterns that may indicate potential problems. Remember that the implementation of these minimum and maximum requirements and recommended procedures should be a collaborative effort involving all stakeholders, including construction companies, electrical contractors, local electrical officials, and workers. By working together, it is possible to create temporary power systems that are both safe and efficient, contributing to a successful and accident-free construction project. Considering all the potential safety hazards associated with temporary power, it is prudent to exceed minimum requirements whenever feasible. The additional investment in enhanced safety measures can significantly reduce the risk of electrical accidents and injuries. This enhanced safety can lead to improved worker morale and productivity, as well as reduced insurance costs and liability risks. It is also important to recognize that temporary power requirements may need to be adjusted based on the specific type of construction project. For example, a high-rise building project may require more extensive temporary power systems than a single-family home project. Similarly, a project involving hazardous materials or sensitive equipment may require additional safety measures, such as explosion-proof enclosures or redundant GFCI protection. Ultimately, the goal is to create a temporary power system that is tailored to the specific needs and risks of the construction project, ensuring the safety of workers and the integrity of the electrical system. The importance of using qualified and experienced electrical contractors for temporary power installations cannot be overstated. These professionals have the knowledge, skills, and equipment necessary to design, install, and maintain temporary power systems that meet all applicable codes and standards. They can also provide valuable advice on how to optimize the temporary power system for safety and efficiency. Remember that cutting corners on temporary power installations can have serious consequences, including electrical shocks, fires, and even fatalities. It is always better to invest in a safe and reliable temporary power system than to risk the lives and well-being of workers. Also consider the impact of temporary power on the environment. Temporary power systems can consume significant amounts of energy, especially if they are not properly designed and maintained. Taking steps to reduce energy consumption, such as using energy-efficient lighting and equipment, can help to minimize the environmental impact of temporary power. Furthermore, it is essential to dispose of temporary power equipment properly at the end of the construction project. This includes recycling materials whenever possible and avoiding the disposal of hazardous waste in landfills. By implementing environmentally responsible practices, it is possible to minimize the environmental footprint of temporary power. In conclusion, temporary power is a critical aspect of construction projects that requires careful planning, installation, and maintenance. By following the minimum and maximum requirements and recommended procedures outlined here, it is possible to create temporary power systems that are both safe and efficient, contributing to a successful and accident-free construction project. Remember that electrical safety is paramount, and temporary power installations should always be treated with utmost care and attention to detail. These requirements contribute to the overall integrity of the electrical systems and safety of workers.